Hello, ladies and gentlemen. I'm Sky Knight. Let's do a bit of a advanced Arch installation today. We're going to be setting up Arch with LVM as well as encryption. We're actually going to be encrypting each individual logical volume that we're going to be creating instead of creating one large partition, encrypting that, and then adding LVM volumes below it. We're going to be, encrypting each individual LVM volume. That way we are able to, maintain the benefits of actually using LVM. You're able to still span multiple drives at a time with one, partition or logical volume. So we're going to be creating volumes for root, for home. We're going to be creating a swap partition. We're going to be creating probably like a game partition as well as a data partition, just so you can kind of get the sense of how you would go about doing all of this, on a real machine, like how I actually have on my physical rig here. But we're going to be going through this on a VM. However, it should be all the same. Let's get into it. All right, and here we have our Virt Manager set up. For this virtual machine, we're going to be using UEFI Arch installation. I'm going to be giving it 12 CPUs, 6 cores, 2 threads each. We're actually going to be passing through 4 separate disks so that you're going to be able to actually see how you would go about, spanning these across disk. Just the standard Arch installation ISO, bridge networking, and I don't believe there's anything else of note in there. Just kick that off. All right, and here we are in the the start screen for the general Arch installation. So a quick note about this is not really going to be a beginner-friendly install guide. You kind of should know what you're doing with Arch before you attempt this, as I'm not going to be going over, how I use Vim or, the general things like that. I have a video that I can link up here somewhere that goes through the process of setting up Arch, for a first-time user. It doesn't use LVM, doesn't use encryption, but it does, basically all the things that you would need it to do. Well, I guess let's get into it. First thing, let's clear the screen there and check out our locked devices. So we have 4 devices. We have VDA through VDD. One of them is 50 gigs, that is VDA. As you see, the rest are 20 gigs. Let's start out by throwing some partitions onto these. The way I'm going to be doing this is I'm going to add 2 partitions to VDA. The first one being an EFI partition, the second one being a Linux LVM type partition. And then for VDB, VDC, and VDD, we are just going to be adding the single partition, but it's going to be of type the Linux LVM. So I'll go through that and I'll meet you back here. All right, and here we have all of my partitions created. As you can see, there's only 1 partition on the 3 drives, and then there's 2 on the VDA. That is solely because we need our EFI partition to be separate from this. So let's create some volume groups. So I'm just going to create a physical volume for VDA, VDB1, VDC1, and VDD1. If you're not sure how to do that, it's PV create, and then the path to the volume. So dev VDA2, dev VDB1, VDC1, and VDD1. And that'll create all your physical volumes. Again, this isn't really an LVM tutorial, but I'll be explaining kind of what I'm doing as I go. Now let's close that out and get that displayed again. All right, next we're going to want to create some volume groups. I'm going to be creating 2 different volume groups. One of them is going to be specifically for, like the operating system, the root file system. I'm going to put home in there as well as a swap file, and then a data volume group. So we're going to throw, our game data or something else on there. Let's span the OS volume through VDA2 and VDB1. To do that quickly, it's VG create, and then the name of the volume group. Let's call it Sky OS, and give it paths to the physical volumes that you have set aside for this. So dev VDA2 and VDB1. Create that. And the second volume group, I'm going to call it Sky Data. And I'm just going to span this across VDC1 and VDD1. And if we check those out, we'll see that they both have 2 physical volumes assigned. You can list out your volume groups with VGS to list them all. Now let's actually create some logical volumes. First one we're going to do is the root file, or the root partition, or not partition, volume. So it's LV create for logical volume create, dash capital L for to determine a specific size. Let's give this, 30 gigs. Dash lowercase n to name it. We're going to call this crypt root. This will just make it easier to differentiate between the encrypted devices and the mapped unencrypted devices later. You'll see what I mean. And we want to tell this to create it on Sky OS. And we're going to do the same with a swap file or swap partition. Let's create this one at 8 gigs. I think I'm providing 8 gigs of memory for this system, so let's just add 8 gigs of swap. I don't usually add swap to installs in general, but it's just showing you how you would go about doing it. So LV create 8 gigs, call it crypt swap, throw it on SkyOS, sure. Now let's create another one, LV, and now we're going to do lowercase l and plus 100% free. And that'll just take up the rest of the space on the disk. Call this crypt home and give that to SkyOS. Next, we're going to want to fill out the Sky Data or volume group. To do that, essentially the same thing. I'm going to make one a size of 15 gigs. Call it crypt data. Well, since the volume group's name is data, let's not call it crypt data. Let's call it crypt backup, in case you want to throw time shift or something back in there. I'll throw that onto Sky Data. I like to have a specific time shift partition on my system, so I'm actually going to change this to be called crypt time shift. And put that on Sky Data, 15 gigs. I mean, 15 gigs is enough for it, but for the purposes of this VM, this training exercise, just call it that. And then we're going to do same thing, this time lowercase l plus 100% free. And then call this one crypt. This could be the game directory. Again, like this is only going to be like 25 gigs big, so fit a game, maybe a game on it. But again, it's just an example. Now if we LVS to see all of our logical volumes, you'll see that they are all there. And actually, if we clear an LSBLK to see all of our block devices, you'll see that crypt root is just on VDA2. Crypt swap is just on VDA2. Crypt home is now spread across VDA2 and VDB1. The time shift is on just VDC1. And crypt games is spanned across VDC1 and VDD1. Okay. Now what we're going to want to do is, first things, well, I guess not first thing, but we are going to need to set our time date here. So time date control, set NTP, true. Just to make sure that we don't forget. Okay, now we kind of do things out of order here. We're going to essentially encrypt and mount the root file system and the EFI partition before we really do anything with the home or the swap or any of the other ones. We first need to encrypt the root device and mount it. So let's do that. To encrypt it, do crypt setup lux format, and then we're going to tell it what to format. In this case, dev sky os crypt root. And I'm going to tell this to use Lux version 2, just because Lux 2 is a little simpler to resize the partition if you need to resize it. One of the benefits of LVM is you can just throw another disk and expand things. Oh, and that did not like something. So crypt setup, Lux format, type Lux 2. And it'll ask you to confirm that, capital YES, and then enter your passphrase. And this will take a little bit to actually go through and encrypt it. Okay, now that it is encrypted, we need to open it up, map it to the file, or kind of map the device to our system so that it can, use the unencrypted version. So crypt setup, open, and then the path to the encrypted device. So sky os crypt root, and then the next one is going to be what we want it to be called in the mapper. So we're just going to call it root and give it the password. And now we are actually able to access that file system. It is on. You can see it in dev mapper. It is called root. It takes the name of whatever you pass it in beforehand. So we call that root. So we get a root device there. So now we can just create a file system for it. So make file system ext4 dev mapper root, and you want to make sure that you're not doing the crypt root or anything like that with this. Otherwise, you're going to be undoing the encryption that you just did. So you want to be making these changes, like actually creating a file system on top of the mapped device. And let's give this a label of root. And now you can just mount it. Mount dev mapper root. Again, you want to mount the root, or the mapper version, the unencrypted one, and mount that at mount. Next, we want to just mount the EFI partition. It is best practice to kind of wipe the partition clean with kind of random data. To do that, suggested use dd. So with dd, input file is dev 0. The output file will be dev bda1, or whatever your EFI partition is, with a block size of 1 megabyte, and just tell us what happens. Okay, so that filled it up with just basically junk data. Now let's make a file system on that. So make file system dot fat32 and put that on dev vda1. And now we're going to mount that onto our mounted device, or our mounted file system now. So mount vda1 onto mount boot. And mount boot doesn't actually exist now, so we're going to want to tell it to make the directory. Okay, now we can run the packstrap command. You can add whatever you want here. I'm going to be adding base, Linux firmware, Linux headers, man DB, man pages, text info, vim, sudo, grub, EFI boot manager, dhcp cd. I think that's all that I'm going to want. Just double checking. Yeah, that's fine. Oh. Mandab, unfortunately, is not a package. All right, and once that gets done, we'll be back. All right, and now we are just after the packstrap command. I know that I forgot to add LVM2 to the list, so we'll have to do that once we chroot into it, or I could just run the packstrap command again, but yeah, whatever. Now let's generate the fs file, or the fs tab tables. So gen fs tab u mount, put that in mount edc fs tab. Okay, now we can hop over. First thing I'm going to do is actually install the LVM2 package. So pacman LVM2. Okay, and now for the most part, we're just going to proceed as normal through the Arch installation guide. We're going to be setting up our time zone, setting up our locale, setting up networking. Basically, once you get to the point where you're supposed to reboot, or if you're going to add a second user, don't do that yet. So I'll just speed that up until I get to that point. Okay, and I have gone through the process of basically everything on the Arch Wiki, down to the root password. Actually, I didn't set up networking. Let's just turn that on now. Okay, there we go. Now we have networking. Now, before we add any other users or, reboot or anything like that, we're going to want to actually make some changes. First thing we want to make a changes to is the makeInitCPIO.conf file. That is in EDC makeInitCPIO.conf. I'm going to jump down to the hooks, and then between auto detect and modconf, we're actually going to want to move keyboard there. So keyboard and key map, and let's get rid of the second keyboard farther down. And then between block and file systems, we're going to want to add LVM2 and encrypt. Right, and save that, and then you're going to want to regenerate that file system. So make init cpio-p. And I suppose you could have done this before you ran the initial command to generate the init file system, but oh well. Next, we're going to want to add or change our bootloader. I'm using grub, so we're going to edit our default grub file, and to get the data, I'm just going to bring my cursor down to an empty line, hit colon to bring up the menu, R for redirect, exclamation point to tell it that we're wanting it to run a command, and then BLK ID. And that will paste in wherever your cursor was the result of that command. So in this case, we're going to want to grab the crypt root, specifically the UUID. I'm just going to go into visual mode and copy that over, and then add a couple parameters onto the Linux default line here. I'm going to do crypt device equals UUID, paste that in. Root, and then root equals /dev/mapper/root. Okay, and then I'm just going to clean this up because it will not like that. Okay. Now we're going to want to set up the swap file to have it essentially automatically load and re-encrypt itself every time. Or not the swap file, the swap partition. Every time the device is booted, it will re-encrypt the swap drive. So to do that, you edit one of the files in EDC. It's EDC crypt tab, or crypt tables. And I'm just going to delete everything from here. Swap is the name. The device will be dev, Sky OS, or whatever your volume group is, and then crypt swap. password, it is going to be a random password every time. To generate that, it's /dev urandom. And then the options we're going to be passing in are swap, telling it what type it is. Cipher equals AES-XTS/plain 64 and a size of 256. And those are all just the recommended options for setting up a swap device. I'll post the link to the Arch Wiki page in the description. So write and quit out of that. Now we're going to want to edit the fstab file. So vim etc fstab, and this is a little bit easier. This we're going to want to do dev mapper swap, because that's what we're calling it. Once it gets unencrypted, it's going to be placed in the swap location. There isn't a mount point for this, so none. What type is it? It's swap. SW for the parameters, and 0 for the. All right, and now we should be good to install grub. So grub install EFI device is boot. Oh, we're gonna need to enter bootloader. ID is grub. Oh, it's not device, it's directory. And then we're going to grub make config show boot grub.cfg. So now we have a encrypted home device, an encrypted swap partition, and an encrypted. Actually, that's it. If we reboot now, you'll be able to get into it just fine. You won't have a home device or a home directory or anything like. Well, I mean, it'll create one, but anyways. So now we want to actually create or encrypt the home device or the home partition, the game partition, and the time shift partition or logical volumes. To do that, we're going to. I mean, we don't want to have to enter in a password for those every time we boot, along with the RIT partition. So we're going to be creating a key folder that will contain a randomized password. Well, it's not. It's randomized when you initially create it. It's not randomized every time. You're not able to access it from outside of the system because it's going to be inside the encrypted system. So to do that, we're going to want to make a directory with 700 writes. So read write exec for root, or the owner, nothing for anyone else. Throw that in /etc/lux keys. Now we're going to want to create 3 separate files. One key file for home, one key file for games, and one key file for the time shift. So to do that, we're going to use dd again. So input file is dev random. Output file will be /etc/lux keys. This one will be for home. Block size of 1, count of 256, and just tell us what's happening. This is essentially creating a 256 character passphrase or password. So we did one for home. Let's do one for time shift, and let's do one for games. Okay, now that we have all those set up, we're going to want to actually encrypt all of those devices. So to do that, we're doing it slightly a different way than before. We're still doing encrypt setup with a LUX format, -v just to make it verbose. We're still passing it the dev encrypt home. So we're still passing everything up until here is the same except for using the verbose. Next we want to, so if you add another parameter here, it will be the key file. So in this case, we want the key file to be etc lux keys home. That's our key file. And type lux2. And that'll overwrite crypt home. Yes, please do that. This will take a little bit to run. Okay, and we want to do that same thing with both the other directories as well. So this would be sky data, and it'll be, instead of crypt home, it'll be crypt time shift. And for the last one, it is Crypt Games. Okay, so we have now officially encrypted the home device, or the home volume, the timeshift volume, and the games volume. Now let's open all of these up so that we're actually mapping them. So crypt setup -d. -d is we're telling it what the key file is. So EDC, Lux keys, home. Then you tell it what we're trying to open. So /dev sky os crypt home, and then just telling it what you want the mapped device to be called. I want it to be called home. Oh, and I did do something that it didn't like. Oh, I didn't tell it what I'm doing. Okay, that makes sense. So after the key command, just tell it to open. And that will grab the key from, or the key from the lux-keys/home. Actually, let's just see what that looks like. /edc lux keys home. Yep, it is a bunch of gobbledygook to humans, but computers can read it. So there you go. So we opened up and mounted, or we mapped the home encrypted device. Now we want to go through and do time shift, and call this one time shift, and games. Okay. Now, if we check out our block devices, you'll see that we have a timeshift mapping, a games mapping, a home mapping. We don't have a swap mapping, but there isn't going to be one because it's a swap device. Okay, now what we're going to want to do is, well, really we can just make the file systems for these. So make a file system ext4. Gonna give it the label of home, and dev mapper home. Make a file system ext4 for timeshift, dev mapper timeshift, and the same for the games directory, dev mapper games. Okay, now let's mount those. So mount dev mapper home to MT home, make directory because it doesn't exist, and you'll get a notification that your FS tab has been modified. It's fine. We'll add it in a little bit. Mount dev mapper timeshift to. So I like to mount, really anything that isn't my home device onto the mount location. So in this case, mount. Ooh, we don't want to actually mount that to home, or mounts home. No, we don't want that because we're already in the file system, so that will be wrong. Let's unmount that and mount it in a not stupid place. There we go. Okay. Dev mapper. Now let's do time shift. So now I want the mount location specified. However, let's call it time shift. And the last one is for games. Okay, and another lsblk to view the system. So /home is mounted, /mnt/timeshift, and /mnt/games is mounted. Root file system is mounted. The boot partition is mounted. Okay, now let's tell. Now we need to add these to the crypt tab file, similar to how we did with the swap file. So vim edc crypt tab. And we're going to create a new line. This one will be for home. So home, device, dev, sky, os, crypt, home. And for the password, it is the /edc/lux keys/home. We don't need any options with it. So the same thing with timeshift, /dev, sky, data this time. encrypt time shift -etc lux keys time shift and games. Dev sky data encrypt games lux keys games, and write and quit that out. So essentially we just added 3 more. We're asking the system to open all of these 3 devices with that open command. We're going to be passing in this key file as the password. Now let's just add those to the fstab table. LVM etc fstab. And like before, go down a couple lines. Dev mapper home. It's going to be mounted on home. It is of type ext4. Just keep the defaults. I think with home partitions, I generally do 0 and 2. Dev mapper timeshift /mnt/timeshift ext4 defaults, and don't worry about checking those. Dev mapper games mount games ext4 defaults 00. Okay. Now we should have everything we need to reboot into this system. We do one last check. All of this. Let's clear the screen first. One last check. So we have our boot partition. We have our root partition, encrypt root. We have our swap partition that isn't acting as a swap right now. However, it will once we reboot. Let's do that. Let's reboot. Exit out of here. Unmount everything. Reboot. Password is required. All right, and here we are already. Let's log in. Oh, and I actually didn't create a user for this. Okay, I'll do that quick. Okay, now let's log in as the correct user. There we go. So we look at our partitions. So we only had to enter in one encrypted password, and we now have our entire system, save the boot partition, is mounted, encrypted. It'll be encrypted at rest. Our swap partition is working. Yeah. Now you're free to install your graphical environment of choice if you would like one, or really anything like that. All right, well, that will be the meat and potatoes of setting up encryption with LVM. It certainly would be simpler to have one large encrypted volume and then add partitions below that. However, you're not able to span multiple disks that way, and I mean, I have multiple disks in my system. I'm assuming you may as well, so this may be helpful for you. Anyways, I'm Sky Knight. Thank y'all for hanging out with me. See you.